Welcome to the introduction to 2D line shape analysis and NMR TITAN software. Two-dimensional line shape analysis is an advanced technique in NMR spectroscopy that involves simulating and fitting entire 2D spectra. Unlike traditional one-dimensional methods, this approach captures complex interactions between molecules more accurately. The 2D spectrum is usually a topographical map. Different methods of transferring magnetization, like CoLC and HSQC, depend on whether the transfer is within the same or different type of nucleus. It provides valuable insights into biomolecular interactions by examining changes in resonance patterns across 2 dimensions, offering a comprehensive understanding of structural, thermodynamic, and kinetic aspects. This method is especially effective for studying multi-step binding processes and resolving overlapping peaks, enabling a more precise analysis of intricate molecular interactions. Early approaches to line shape analysis of 2D spectra were based in the integration of cross-sections through or across rectangular regions to which traditional 1D line shape analysis could be applied. This is limited by the requirement to avoid overlapping resonance, and it introduces uncertainty due to the need to normalize the area under each cross-peak, which may be highly broadened by chemical exchange. Also, this technique does not accurately consider the evolution of magnetization through the full pulse sequence, and it introduces errors by neglecting differential relaxation in slow intermediate exchange regime, phase distortions, and cross-peaks from chemical exchange during mixing and chemical evolution periods. Previously, NMR line shape analysis was applied to 1D NMR spectra, but the analysis of macromolecules, which contain a large number of 1H resonances, requiring multi-dimensional spectroscopy to resolve spin systems. TITAN is a true 2D line shape approach. The method is based on the use of a virtual spectrometer to propagate an initial density operator through the entire experimental pulse sequence. Extracting information from NMR resonance line shape can be challenging due to peak overlap in complex systems and errors from applying 1D framework to 2D data. The 2-dimensional line shape analysis can be incorporated into the TITAN software package, which simulates NMR pulse programs like HSQC and HMQC for protein ligand interaction monitoring. TITAN supports various binding models, from simple two-state interactions to complex mechanisms like induced fit or conformational selection. This software is useful as it improves accuracy. It utilizes the bootstrap error analysis method based on resampling fitting residuals in 2-dimensional blocks. This is a unique aspect of the bootstrap error analysis method, as it considers correlation between neighboring points and provides more precise uncertainty estimates than conventional point-based resampling. There are 3 ways in which you can get access to TITAN software. 1. Download a standalone version. 2. Run through NMR Box. Or 3. Run in MATLAB. The information is in the link on the slide. First, you have to register to join the user list, then create a Bitbucket account, and once you are registered, you'll receive an invitation to join the TITAN repository. TITAN is free for all academic users. From Bitbucket, you'll be able to download the most current stable version or a developmental version of TITAN for Windows, OS X, and Linux. The installation scripts can be found under the folder titled bin in Bitbucket. To access TITAN through NMR Box, create an NMR Box account, go to the software page and scroll down until you find TITAN. You should find yourself on a page like this. Click View Available VMs for the most recent software version. Choose a server with an available CPU load and download it. Download a VNC viewer to be able to view the VMs. There is also one linked on the slide. To be able to access TITAN through MATLAB, the source code is in the TITAN directory, which should be added to the MATLAB path before starting any analysis. Use Path tool to add the TITAN directory to the path and close. Run TITAN to launch the graphical user interface for analysis.